report on something that touches the lives of just about every American, our caffeine craze.
Caffeine is everywhere. The fact that 90% of Americans seek out caffeine each day would probably laugh if told that too much could kill them. Have we become too comfortable with this potentially toxic substance? After all, it is in many of the drinks we consume. What many of us do not know is that caffeine is not naturally found in these drinks. It has to be added to them artificially. You see, caffeine is often extracted from natural plants like coffee beans, and then is added to our common drinks like soda pop, energy drinks, and no-dose pills to give them an extra boost. But there is a danger. Over 20,000 people, many under the age of 20, were hospitalized from caffeine overdose. In 2012, the Food and Drug Administration reported 13 deaths from 5-Hour and Monster energy drinks. These types of drinks have no caffeine regulations.
Caffeine is a naturally occurring organic nitrogen-containing ringed molecule that has pronounced physiochemical actions on humans. It is odorless with a bitter taste and is one of a few alkaloids that are soluble in water. Humans consume over 250 million pounds of caffeine each year, most of which is extracted from plant matter and then artificially added to drinks.
Let's look at how caffeine works on people. If we look inside of our brains, we will find a vast and dense array of nerves and synapses that conduct electrical signals. At the end of these connections, or axons, we will find chemicals that are emitted called neurotransmitters. These are received at receptor sites on nearby dendrites. Let's take a look at these neurotransmitters more closely. You see in our illustration that adenosine bonds to receptor cells in our brain, and that produces a calming effect on our nervous system. This makes us sleepy. But when caffeine is present, it sort of gets in the way. It blocks adenosine from the receptor, and we don't feel sleepy. Caffeine attaches to these neuroreceptors before adenosine can, whereby causing our nervous system to be stimulated. This is why we call caffeine a stimulant. And as it stimulates our nervous system, we observe increased heart rate, elevated blood pressure, and heightened alertness, all of which taken to an extreme can cause physical harm to our bodies. Doctors recommend teens consume less than 200 milligrams a day. This is less than 24 ounces of coffee. More than 400 milligrams a day is considered dangerous, and 3,000 milligrams a day is potentially toxic to adolescents. Drinks like coffee and soda have low enough levels of caffeine that one would have to drink a very large amount. Caffeine can become dangerous when it is presented in concentrated or pure form. Drinks like Red Bull, Monster, and 5-Hour Energy contain as much as 500 milligrams of caffeine. That's 10 times the amount of caffeine that is found in a can of Coke. One might be asking, so how do manufacturers get all that caffeine into their products? Caffeine extraction is a chemical process that can be done using a variety of solvents. The most popular methods for extracting caffeine involve the use of ethyl acetate, methylene chloride, or one of the two simpler ways like water or CO2. Indirect solvent extraction processes may start by using hot water to extract caffeine from roasted coffee beans to make coffee. A solvent that is immiscible with water, like methylene chloride, is then mixed well with the water. The caffeine is extracted from the water into methylene chloride due to the very polar and aprotic characteristics of this organic solvent. Isolating the caffeine is as simple as boiling away the methylene chloride solvent. A more direct extraction method that is free of the environmental concerns that come with organic solvents includes the use of carbon dioxide. The key is that the CO2 is used at its critical point where it is at a supercritical fluid. That is, it possesses the properties of both a gas and a liquid at the same time. As a supercritical fluid, it has the density and viscosity of a gas, while at the same time it has the solvating power of a liquid. More producers are turning to this relatively limited use direct extraction technique. The process starts with green coffee beans. The beans are first soaked in water to make them swell and allow the supercritical CO2 to penetrate more easily. It is also thought water may be needed to help free the caffeine from chemical complexes in the bean. Supercritical CO2 is circulated for up to 10 hours through the pre-soaked beans in a high-pressure extraction chamber. In the second vessel, water and the caffeine-rich carbon dioxide are passed in opposite directions and the caffeine dissolves in the water. The carbon dioxide is repressurized and reused. Caffeine is recovered from the water as a concentrated solution using one of a range of processes, including reverse osmosis. This concentrates the caffeine further. With chemical extraction techniques, we are able to extract about 1.5 grams of caffeine from 100 grams of coffee beans, and a mere teaspoon of caffeine weighs 6.06 grams. That's over 6,000 milligrams of caffeine. This is the equivalent of more than 30 cups of strong coffee all in one gulp. You can overdose on caffeine. Too much can cause seizures, erratic heartbeats, and even death. Currently, caffeine is not regulated in food products by the FDA. It is completely legal and readily available. In its pure white powder form, the difference between a strong pick-me-up and death is a very small amount. Recently in the news, we learned of a teenager's tragic death resulting from a small error they made in how they measured it out. Doctors say that death or heart attacks attributed to too much caffeine are under report because there are typically caffeine in the system. So before fueling up our bodies in our caffeine craze, stop and think. It's not just a drink, it's a drug. Treat it with respect. That's all for our report. We hope you learned something new and we'll come back for more.